So, um, I think tomorrow we're going to learn about infinite limits
Mm-hmm.
and limits at infinity.
Limits at infinity. Okay. Okay, so first let's understand limits and continuity, and then from the next class, like from the next Monday, you every Sunday drop me an email that what you will be doing in Tuesday's class. Okay, so we'll cover that in every Monday's class. Like we'll try to cover 1 week's curriculum in one class, whatever you'll be doing in that entire week. We'll try to finish that in Monday's class. Okay, so Anika, first of all, in Unit 1, you have 1.1, which is about can change occur at an instant. This is the core concept of limits. Instantaneous change. See, there are two types of changes. One is average change, average rate of change, average rate of change, and then we have instantaneous change. Instantaneous change. Do you know the difference between these two types of changes?
Um, like average change,
Hmm.
like average rate of change is like when it's like changing by like a certain value, like a standard value, I think.
Standard value. This is kind of, you're right, average rate of change is actually the change defined over an interval. Okay, for example, here from this to this interval 2 to 7, if you want to find out how this function is changing from 2 to 7, that's an interval from 2 to 7, that's your average rate of change. Okay, so it's not different than the change that you used to find out in linear functions. See, right now this is not a linear function, this is a non-linear function.
Okay.
But you remember how we find out change in linear functions? We used to do it by taking rise over 1.
The what? Yeah, y over x.
Yes, so like change in the y values over change in the x values. Now in calculus, you will see the symbol of triangle to represent change. Okay, wait,
Delta.
delta, exactly. So this is delta y over delta x. Delta, we use delta to represent change over a very small interval. Okay, if your interval is very small, like really small, then change in that interval we denote by the symbol delta. Okay, see, right now if you find out the change delta y over delta x, what will that be? So if you're moving from this point to this
Like,
point,
okay, so 3 minus 2 over 2 minus 7. So 1 over negative 5.
exactly, so negative 1 over 5, that means when we are going from this point to this point, we are traveling a distance of 5, like horizontal distance of 5, and we are coming down by 1 unit. That's the change in this interval from 2 to 7. Now limits, if we want to find out the limits, we will make this interval smaller and smaller and smaller. Okay, smaller and smaller and smaller. So if I make this interval this much, if I make this interval this small, then again small, then again small, and then we'll make it as small as possible. Okay, as small as possible. Okay, now first of all, you should know that the length of the interval is denoted by the letter h. Okay, the length of the interval is denoted by the letter h, and your average rate of change, it's also given by f of x minus f of a over x minus a. Okay, Anika?
Okay.
X and a are just random points like 2 and 7 that we took. Okay, so like function's value at x and a, this is nothing but this is same as delta y and this is same as delta x. X and a are random points. Now when we make the interval really small, then we use this formula, f of x plus h minus f of x over h. This h is usually the smallest length possible for the interval, the smallest length that you can take for the interval. Okay, and
Okay.
see, h, the interval, it will never
Mm-hmm.
become 0. The points will never coincide with each other. There will be very small width of the interval, and that's why we say that the limit when h approaches to 0, this arrow means that h is approaching to 0 or tending to 0. Okay, that means h is becoming really small, like 0.000000001, but not exactly 0. Okay, and here if I want to make this interval small, that means I need x to become equal to a. I mean the 2 points x and a, they should be very close to each other. Like if one point is 2, then the other point will be 2.000000001. Okay, so x will become like x will tend to become a but not become exactly equal to a. So that's your concept of limit, and this is your instantaneous change. This is instantaneous change, the change that is happening at an instant. Okay, Anika, and now we'll see how to find out the limits of functions. Okay, let's say that we have some data given to us in tabular form. Okay, there is a
Okay.
function and the values are like 5, -8, 7, 1, 9, 6, 11, -2, 13, -3, and we have to find out the instantaneous change when x is equal to 8. When x is equal to 8, see now in this question, in the table, do we have x as 8? Do we have any value of x as 8?
No.
No, right? We have 7 and 9, but we don't have 8. Okay, so in these type of problems, what we do is, obviously 8 will be between 7 and 8, right? Somewhere here 8 will be there. Okay, so that means you have to come to 8 from the left hand side and from the right hand side. Okay, see, I don't know what's the graph of this function. It can be anything, and let's say this point is 8. Okay, but we don't know the values of the function at 8, but we know the values of the function at 7 and 9. At 7 the value of the function is 1, and at 9 the value of the function is 6. So we don't know the value of the function at 8, so we will try to approach the function from left hand side and from the right hand side. Okay,
Okay.
so this point becomes x and this point becomes a, and we can use this formula. Okay, we can use this formula. So f of x minus f of a, f of x minus f of a over x minus a, and here x is tending to 8. X is tending to 8. We are approaching 8. Okay, Anika, so let's find out what is f of x. X we have taken as 7, x we have taken 7, and a we have taken 9. So f of 7 is what?
F of 7 is 1.
F of 7 is 1 minus f of 9.
F of 9 is 6.
F of 9 is 6, and then x minus a, that means 7 minus 9. So this is going to be negative 5 over negative 2, or 5 halves. Okay, so limit of the function when x approaches 8 is 5 halves, or 2.5 basically. Okay, Anishka?
Okay.
This is how you can find out the limit or instantaneous change when tabular data is given. Okay, now you should know the limit notations, and now we'll find out the limits when graphs are given. Okay, when the graphs are given. And this is the type of questions that you can expect in your tests, in your quizzes, in your assignments. Most of the questions will be based on graphs. Okay, so first of all, what's happening when we are trying to find out the limit? Let's say, Anishka, that we have this point. This point is 2 comma 4. Okay, this is 2 comma 4, 1, and this point is 2, and this height is, let's say, 4. So 1, 2, 3, 4. Now I am interested in finding out the limit of this function. Let's say that this function is f of x, and I want to find out what will be the limit of this function when x approaches to 2. Okay, now whenever we have to find out the limit, Anika, we will approach the function from both left hand side and from the right hand side. So we will approach from the left hand side, also from the right hand side. Okay, and if we get the same value of the limit from coming from the left hand side and by coming from the right hand side, only then we can say that the limit of the function exists. You will see in many functions, left hand, like when you approach from the left side and when you approach from the right side, you will get different limits. We'll do some example of different limits. So Anishka, in this case, what should be the left limit and the right limit? Will it be same or will it be different in this case? Then we come from the left hand side.
It'll be the same.
It'll be the same. In this case, it is the same. No matter if you come from left side or you come from the right side, the limit of the function will be 4. When x approaches to 2, the function is approaching to 4. Okay, that was the easiest example just to show you what's the meaning of limit. And so there will be two types of limits, Anika, as I have been mentioning: left hand limit and right hand limit. It's abbreviated as LHL and RHL. Okay, so we will now do a problem based on left hand limit and right hand limits. And let's change the background for this. After that we will do the 3 cases to find out the limits. Let's make them thicker. Okay, Anika, I'm gonna draw the graph of a function. It's a really like discontinuous function. A discontinuous function is the one which has lot of like breaks. Okay, we'll do the discontinuous function as well. Okay, so see, I have let's say this point is 1, this point is 2, and then we have 1, 2, 3, 4, 5, 6, and just 7. Okay, so from 1 to 3, the graph of the function looks like this. So we have a break on 3, and the function is like this. This is an oscillating function. Have you seen this function, Anika? This kind of
Yeah.
function? Yes, this is called an isolating function. Sorry, oscillating function. And then from 3 to 4, 3 to 4 is like this. Okay, and then from 4 to 5 we have graph kind of like this. Here we have an asymptote at 5. You do you know about asymptotes, Anika?
Yes.
Okay, so at x is equal to 5 we have an asymptote, and here you have a open circle. This is the open circle, and then from 5 to 7 it is kind of like this. At x is equal to 7 we have a cusp, and then it's a straight line. Okay, now I will remove the background. This is the weirdest function ever, and now we will try to find out the left hand limit, the right hand limit at all the points. Okay, so left hand limit, right hand limit, and then the general limit. GL is your general limit. Okay, Anika?
Okay.
Okay, so first, when x is equal to 1, let's see what's happening at x is equal to 1. X is equal to 1 is this point. So when x is equal to 1, the function is oscillating. What do you think is the value of the function when you approach x is equal to 1 from the left hand side?
I thought these type of functions didn't have limits.
Exactly. The oscillating functions, see, it will have limit at some points and it will not have limits at other points. Okay, at x is equal to 1 it is oscillating. Whenever you see an oscillating function, the limit will not exist. The left hand limit will not exist, so we write D and E, does not exist. The right hand limit will also not exist, and if the LHL and RHL both do not exist, then the general limit will obviously does not exist. Okay,
Okay.
because when it's oscillating it does not have a fixed value. At x is equal to 1, if you will approach from left side and right side, it will have different values. Okay, Now let's talk about x is equal to 3. Now when you're coming from the left side, we have to find out the left hand limit and right hand limit separately.
Okay, so
So when you're coming from, you want to approach 3 but from the left side. So what's the value of the function? When you're coming from left side, see, this is the graph. When you're coming from the left side, Anika, so you're coming from here.
yes,
So you
like
have
from the
what?
so
So we have to see this value, this one, right before this circle.
so then won't it not exist?
The general
Wait, no,
limit,
it's the limit, so that means it'll be 3.
3. No, 3 is the x value, and at 3, what's the y value of the function?
1.5.
1.5, yes, exactly. When we're coming from the left side, the value of the function is 1.5. And when you're coming from the right side, that means now you're approaching from this side. Then what's the value of the function?
Then it's 1.
Then it's 1. Okay, so now in this case you see the left hand limit is 1.5, the right hand limit is 1. So since your left hand limit and right hand limit are not equal, so that's why we will say that its general limit does not exist. For the general limit to exist, both LHL and RHL should be same. Okay,
Okay.
now let's see at x is equal to 4. At x is equal to 4. At 4 you have this open circle. I want to draw it slightly below. Wait. This is okay. So approach it from the left side. Approach it from the left side. What's
So from the left side,
mm-hmm.
won't it be the same?
Yes, so if you're approaching from the left side, it is 1.5, and you approach it
1.5.
from the right hand side, even
It's
then
also 1.5.
also 1.5. So 1.5 and 1.5. So in this case, the general limit will exist and it will be equal to the value of the LHL and RHL. So this time the general limit will be 1.5. Okay.
Okay.
And now we have a point on asymptote. X is equal to 5. So what's happening when x is 5? What is the value of the function from left side and from the right side? From
I
left
thought
side,
for asymptote, like there won't be one
there won't be what?
because it'll never like reach that number. Like it'll
Yes.
never reach x is equal to 5.
No, x is coming to 5, x is approaching to 5. Then the value of the function, if you see the graph, this is moving infinitely in the top direction. Like y values we have to see. The y values are increasing and increasing. X is 5, so the graph is approaching this line, but you have to see the y values. They are increasing like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way to positive infinity. Okay, so in this case, when you have a vertical asymptote, when you're approaching from the left side, the value of the function is tending to positive infinity. And when you're approaching from the right side to this graph, like when x is tending to 5, the function is decreasing. See, you'll go all the way in the negative direction.
So negative infinity?
Negative infinity. Okay? And since both LHL and RHL are not same, so the limit does
Well,
not,
then that means it does not exist.
it will not exist. And one final point, when you have a cusp, see, this point is called a cusp. A cusp is that point where the concavity of a function changes. Have you done concavity?
Yes.
Yeah, so this is where concavity is changing. And so this is x is equal to 7. What do you think about the limit at this point, Anika? X is equal to 7.
Well, won't it be like 0.5 from both sides?
Yes, 0.5 from both sides, and that's why the general limit will be also 0.5. So see, whenever you have a smooth point, like this is not a smooth point, we don't call it a smooth point, but if you take any smooth point on the graph, like for example, if you take x is equal to 6, so limit will always exist at a smooth point. Okay, here the limit will be 1, right? From left hand side and from the right hand side, the limit y value is 1. And even if you take any point here or here, these are all smooth points. So limit of the function at smooth points will always exist, and it will be the y value. Okay, Anika, so are these all the cases clear? We took a case of oscillating, graph is oscillating, then we took a discontinuity. See, this is the case of, we will do discontinuity in detail. When you see a break or a jump in the graph, that's the case where we say that this is function is discontinuous. And we also saw the case of asymptote, and we saw the case of cusp. So these are the all possible cases that you could get on a graph when you have to find out limit of a function. You will get either one of these cases. You'll either get oscillating function, or you'll get a discontinuous function, or there will be asymptote, or there will be a cusp. Okay?
Okay.
So this is how you find limits through graphs. And now we will do how to find out limits analytically. Okay. So Anika, there are 3 ways to find out the limit of a function. Okay. The first way is direct substitution. Direct substitution. Like whatever is the value of x, we directly put it. But most of the times it will happen that when you directly substitute it, you will get like an indeterminate form. Wait, or like everything will become 0 over 0. Those are there are 7 indeterminate forms. We will discuss all those forms. Second way is factor and cancel. Third way is you rationalize if you see square roots. And fourth way is the L'Hopital's rule. L'Hopital's rule is useful when you get the form 0 over 0 or infinity over infinity. Have you done the L'Hopital's rule?
No.
No, not yet.
No.
Okay, so we'll do these methods one by one. Okay, so first we will do examples of direct substitution. So we have to find out the limit of this function x square plus 2x minus 4 when x approaches to -1. This is the function. This is the easiest kind of problem because if you directly substitute x is equal to 1, then we will not face any trouble. We can just put x is equal to -1. So Anika, there are some indeterminate forms. You should know the forms. The indeterminate forms are 0 over 0, infinity over infinity, 0 times infinity, 0 raised to infinity. If you get any of these forms, then we cannot directly substitute. We cannot use the method of direct substitution. This is the method of direct substitution. So what will you get if you put x is equal to -1?
-5.
-5. And the answer will be, so the limit will be
-5.
-5. Okay, let's do one more. Can you find out the limit of this function root 3x minus 2 when x is approaching to 2?
Wouldn't it just be 2?
2. Yes, so this will be 2. So in these problems, Anika, we could directly substitute the x value because we did not get indeterminate form. Now we will do the method of factor and cancel. Method number 2, factor and cancel. Now, for example, if you have this problem, we have to find out the limit of the function 4x square minus 5x over x when x approaches to 0. Now if you will directly substitute x is equal to 0, then what will you get? If you use direct substitution here,
Then don't I get like 0 over 0?
0 over 0. So that's why we cannot use the method of direct substitution because 0 over 0 is an indeterminate form. Okay? And 0 over 0.
So we have to factor and cancel?
Yes, in this problem we can use factorization because in the numerator we can factor out x.
So
Factor out x, then what will you get? (4x minus 5).
4x minus 5. And then -5?
Yes,
Because
I mean
you
the
can't
answer. Yes, the final answer you mean. Okay. So x and x will cancel out. So we have cancelled. And now if we directly put x is equal to 0, so now we'll get the limit as -5. Okay. Let's try one more of factor and cancel. You have to find out the limit of 2x square plus 13x minus 7 over x plus 7 when x approaches to -7. Again, if you directly substitute -7, you will end up getting 0 over 0.
Okay.
This is 0 over 0 form. So what should we do in this case?
have to factor
We should factor.
2x plus.
So what will you factor in this case?
Um, well,
I think we cannot factor out a single number from all the three terms of the
yeah,
numerator, but it is a quadratic expression. So can you like write its linear factors? We did, by using the factorization method.
yeah, I'm trying to do that,
Mm-hmm.
but I always struggle when there's like a coefficient in front of the x squared.
So whenever you have a coefficient of x squared, like it's not 1, so multiply 2 and negative 7 first. Multiply a and c. So 2 and negative 7 will be
-14.
negative 14. Now you find out factors of negative 14 so that by adding them you get 13.
So like -2 and 7 or -7 and 2.
But if you add them, you should get 13, the b value, right?
Mm-hmm.
So, um,
So 14 and -1.
14 and negative 1, yes, that's true, that's correct. 2x squared plus 13x minus 7. Okay, so I can write 13x as 14x minus x, right?
Mm-hmm.
13x can be written as 14x minus x, and now just factor out, you can factor out 2x from the first two terms to get x plus 7, and factor out negative 1 from the last two terms, and then factor out x plus 7. So what will you get when you factor out x plus 7?
Then I get wait. Mm,
When you factor out x plus 7, see x plus 7, x plus 7.
yes. So I can only get rid of 1, right? So wouldn't it be like 2x times -1 times x plus 7?
Yes, so when you're factoring out x plus 7, so what's remaining is, what's left, 2x and negative 1. That will be your other factor.
Hmm.
These
Right.
are your two linear factors. So you can write this function as, now your numerator is factored into two linear factors. Your x plus 7 times 2x minus 1. So now you can cancel out x plus 7, right?
Would it still give me 0? Oh wait, no.
No,
Oops.
now x plus 7 is no more there. Now substitute x is equal to negative 7. Now the function is this, 2x minus 1. That's it.
Okay, so negative 15.
Negative 15 will be the limit. So this is how we find out the limits by factor and cancel, Anika. The third method, we'll quickly do the third method. It is L'Hopital's rule. But for L'Hopital's rule, have you done differentiation in school?
Um, no.
No, okay then. We won't be able to do L'Hopital's rule. In L'Hopital's rule, we just differentiate the numerator and denominator, but for that we will first learn differentiation. Differentiation is itself another whole unit. Unit 2, I think in unit 1 only, it will take 3 to 4 classes to complete differentiation.